Namaste children, welcome to today's maths class, and today I am going to introduce chapter number 6, Lines and Angles. Lines and Angles. So you are familiar this concept even in class 7th, you have 5th chapter, Lines and Angles. So there we studied different types of angles, different types of lines and angles made by these lines, especially transversal, and the angles made by the transversal we have studied in class 7th. So what we have covered in class 7th, all those concepts again will be covered in this chapter, and much problems, more problems will be there. Those problems we need to solve by using those properties related to lines and angles. So now I'll give you introduction. So introduction of this chapter, some terminology related to this chapter, that is point. Point. What is a point? A point is a dot with the pencil which we keep like this. Yes, this is a point in geometry. Those points are represented with capital alphabets, English alphabets, capital alphabets like point A, point B, point C, point X, point Y, point Z, and etc. So now that is the first term, it is point. Then what? Line. What is a line? A line is a group of points which extends endlessly on both the sides. When you join a group of points like this, yes, these are the points. So few points are, when you join these points and extends endlessly on both the sides, that geometrical figure is known as line. And the lines are represented with what type of letters? Yes, they are represented with small case English alphabets, small letters like A, line A, line B, line C, line D, line X, line Y, line P, line Q, like this will represent. And also with two capital letters will represent a line. Yes, if this is point A and point B, how do we represent as line AB? Like this will represent line AB, line XY, line PQ, like this with two capital alphabets also we will represent lines. Now line, then line segment. Line segment. Yes, line segment. So what is line segment? Segment means a part. Line segment means a part of the line. A part of the line is known as a line segment. You see, this is line AB. AB, this is a part in the line. This is a part in the line. This part is known as line segment. So how do we draw the line segment as? Yes, this is line segment AB. A part of this line AB is the line segment AB, line segment PQ, line segment XY. So line segments are represented with two capital letters, and it has two end points. A line has no end points, whereas a line segment has two end points. Now ray. What is a ray? A part of the line with one end point. A part of the ray with one end point. Yes, like this. This is a part of the ray A and it is B. This is called AB ray. Like this will represent, and we will read AB ray, PQ ray, like this. PQ ray will represent like this. PQ ray or XY ray, like this rays. So then angle. What is angle? An angle is the geometrical figure which is obtained by joining, by the fusion of, by combining two rays with their end points. Yes, this is one ray with end point A, and one more ray AC with the same end points. So when these two rays join together forms a geometrical figure. This geometrical figure is known as angle, and these two rays are known as what? These two rays are known as arms of the angle. What are these? Arms of the angle. Arms of the angle. Now what we call this point? The common end point vertex of the angle. And how angles are represented? This angle BAC. This is angle BAC or angle CAB, or even with one letter we represent it is angle A. So like this we represent angles. So parts of angles are ray, line segment, line, point, all these things we covered now. Now what are the different kinds of lines? What we are going to study? Yes, the lines, if two lines are there, they may intersect, they may not intersect. That is intersecting lines, non-intersecting lines. Intersecting lines are like this. Yes, these kind of lines are known as what? Intersecting lines. Yes, they are intersecting lines. Now if you take, yes, this is also one pair of intersecting lines. Why? Because when we extend this line, they intersect each other. So like this, angles will be in the form of intersecting lines. Now what about these lines? Yes, these lines are what? They are non-intersecting, or they are also known as parallel lines. So intersecting lines, they intersect each other at one point. This point is known as point of intersection. What is this? Point of intersection. That point of intersection is the common point for both the lines. It is the common point for both the lines. Whereas for parallel lines, as these two lines are not intersected, so they don't have any common point. So here no common point. For parallel lines, no common point. Whereas for intersecting lines, we will find one common point. Now what we call this kind of lines? Yes, this is one line L, and one more line, this is M. Line M and L, both are what? They are overlapping with each other. Such kind of lines are known as coincident lines. What are these lines? Coincident lines. Yes, these kind of lines are known as coincident lines. Whereas now one more kind of, yes, if more than two lines passes through the same point, like this, if they pass through the same point, what we call these kind of lines? Yes, they are concurrent lines. These lines are known as concurrent lines, and this point is known as point of concurrence. Yes, this point is known as point of concurrence. Like this, intersecting lines, parallel lines, coincident lines, and concurrent lines. The last kind of lines, yes, here I'm drawing. Yes, what we call these lines, children? Yes, these kind of lines are also intersecting lines, but they intersect each other at 90 degrees. That is perpendicular. So we call these lines are perpendicular lines. What we call these lines? Perpendicular lines. And they make an angle of 90 degrees. That is a right angle. So this is about different kinds of lines. Now we will discuss different kinds of angles. Is it clear? Now, types of angles. Yes, we have come across different types of angles. So the first type of angle is zero angle. What is this? Zero angle. So what is zero angle? An angle whose measure is 0 degrees is called zero angle. An angle whose measure is 0 degrees is called zero angle. Then what we call the angles which are more than 0 degrees and less than 90 degrees? Yes, they are acute angles. So what are acute angles? An angle whose measure is more than 0 degrees and less than 90 degrees. Yes, let x is an angle which is more than 0 degrees and it is less than 90 degrees. Such kind of angles are known as acute angles. Yes, acute angles. Examples we can write different kinds of examples. Different examples for acute angles like 1 degrees, 15 degrees, 75 degrees, 89 degrees, 89 60 degrees, 45 degrees and so on. Now, what we call an angle which is exactly equal to 90 degrees? Yes, that angle is known as a right angle. So, right angle. So, what is a right angle? An angle whose measure is 90 degrees. Such angles are known as right angles. Now, what we call the angles which are more than 90 degrees and less than 180 degrees? Yes, they are obtuse angles. Obtuse angles are obtuse angle. So, what is obtuse angle? Which is more than 90 degrees and less than 180 degrees. Let x is an angle which is more than 90 degrees and less than 90 degrees, less than 180 degrees. Such angles are known as obtuse angles. Now see examples for this. It is 91 degrees, 135 degrees, 150 degrees, 150 degrees, 165 degrees and 179 degrees. All these angles are obtuse angles. Now what we call an angle whose measure is 180 degrees? Yes, it is a straight angle. Acute. Then it is a straight angle. So what is a straight angle? Straight angle. So an angle whose measure is 180 degrees. Such angles are known as straight angles, or it is a straight angle 180 degrees. Now what we call it is more than 180 degrees and less than 360 degrees. Yes, it is a reflex angle. A reflex angle. So what is a reflex angle? An angle whose measure is more than 180 degrees and less than 360 degrees is known as reflex angle. Examples for reflex angles: 181 degrees, then 200 degrees, 300 degrees, 359 degrees, etc. Now what we call an angle whose measure is 360 degrees? Yes, it is a complete angle. It is a complete angle. So what is a complete angle? Yes, an angle whose measure is 360 degrees. Such angles are known as complete angles. An angle whose measure is 360, that angle is known as complete angle. Now, you see, if you come observe this in the form of figures, complete angles. What kind of angle yes it is? Yes, this is an acute angle, and this is what kind of angle it is? Yes, this is an obtuse angle. This is acute angle, and it is obtuse angle symbolically. And what we call this angle? Yes, this is angle in the straight line. This is 180 degrees, straight angle. What is this? A straight angle. A straight angle. It is a straight angle. Straight angle, yes. It is a straight angle. Now, what we call, what is this angle is known as? It is more than 180 degrees. It is a reflex angle. Reflex angle. And what we call this angle? Yes, it is a right angle. This is a right angle. Now, and what we call this angle? Yes, this is what we call this angle. This is a complete angle. A complete angle. Like this. These are the different types of angles. Now, two more types. Complementary angles. Complementary angles. So, what are complementary angles? A pair of angles. A pair means two angles. A pair of angles whose sum is 90 degrees. A pair of angles whose sum is 90 degrees are called complementary angles. Here the pair of angles both are what? Both are acute angles. Complementary angles are what? A pair of angles means two angles whose sum is 90 degrees. See for example 30 degrees, 60 degrees. This is one pair whose sum is 30 plus 60, 90 degrees. Complementary angles. And 50 degrees, 40 degrees is one pair of complementary angles. 25 degrees, 65 degrees is one pair of complementary angles. So if we know one complementary angle, we will find the other complementary angle by subtracting the known angle from 90 degrees. What is the complementary angle which is equal to itself? Yes, it is 45 degrees. 45 plus 45 is 90 degrees. Here both angles are acute angles. Both the complementary angles are acute angles. Now, the one more type is supplementary angles. Supplementary angles. What are supplementary angles? Again, these angles also a pair of angles means two angles whose sum is 180 degrees. A pair of angles whose sum is 180 degrees. Such angles are known as, their sum should be equal to how much? 180 degrees. Such angles are known as supplementary angles. Yes, 60 degrees, 120 degrees. Their sum 60 plus 120, it is 180 degrees. 50 degrees, 130 degrees. This pair also will form a pair of supplementary angles. Can these two angles 75 degrees and 105 degrees will form a pair of supplementary angles? Yes, 75 plus 105 is 180 degrees. Will this pair of angles form a pair of supplementary angles? 40 degrees and 150 degrees. 40 degrees and 150 degrees. 40 plus 150 is how much? It is 190 degrees. Will they form a pair of supplementary angles? No, they do not form a pair of supplementary angles. That is, their sum should be equals to what? 180 degrees. A pair of angles whose sum is 180 degrees are called supplementary angles. A pair of angles whose sum is 90 degrees are called complementary angles. Is it clear, children? Different kinds of angles. Yes. Now we will continue few more angles like vertically opposite angles. When two lines are intersected each other, how many angles are formed? 4 angles are formed. These 4 angles, yes. And two pairs of opposite angles are there, like 1, 2, 3 and 4. Angle 1, 2, 3 and 4. Here angle 1 and angle 2 both are opposite to each other, and angle 3 and angle 4 are both are opposite to each other. That is angle 1, angle 2 and angle 3, angle 4. We call this pair of angles are vertically opposite angles. Vertically opposite angles. Remember, vertically opposite angles, and we have a theorem about the nature of vertically opposite angles. That is theorem 6.1. We will study in detail its proof and statement. Now, adjacent angles. Next we have adjacent angles. So what are adjacent angles? Adjacent, the word adjacent means side by side. So a pair of angles which have one common endpoint, a pair of angles which have one common endpoint and one ray is common, such pair of angles are known as adjacent angles. Yes, you see here, this is, yes, A, B, C and D. Here two angles are formed, that is angle ABC, this angle, and angle CBD. Two angles are formed. These two angles have one common arm and common endpoint, common vertex. So this kind of angles are known as adjacent angles. They are called adjacent angles. They have they have two non-common, one common arm is there, and these two are called non-common arms, and this is a common arm for both the angles. So this is one pair of adjacent angles. You take one more ray, yes, like this. Now here we have two angles are there. Can we call these two angles are adjacent angles? Yes, we call these two angles are adjacent angles when this is A, B, C and D. So these two pairs of angles are also called adjacent angles because they have a common arm or common ray BC and two non-common arms AB and BD, the common vertex B. So this pair is also adjacent angles. Now can we call these two angles are adjacent angles? Yes, these two angles are adjacent angles. No. Why? Because they don't, though they have the common arm, but they don't have the common vertex. These two are not adjacent angles. So you should know the meaning of adjacent angles. adjacent angles. See the second figure. And also the sum of these two angles is equals to sum of these two angles, that is angle ABC and angle CBD. Their sum will form a straight angle, that is 180 degrees. This kind of angles are known as linear pair of angles. Remember, linear pair of angles. Pair means two. Linear pair of angles. So generally the meaning of linear pair of angles means linear means a straight line. The two angles formed on this straight line whose sum is 180 degrees. Whose sum is 180 degrees, that is angle 1 and angle 2. Angle 1. If angle 1 plus angle 2 is equals to 180 degrees, then we call this pair of lines are angles are linear pair of angles. So a pair of adjacent angles whose sum is 180 degrees or whose measure is 180 degrees, such pair of angles are known as linear pair of angles. Linear pair of angles. Now this is angle 1 and angle 2 will form 180 degrees. This is a linear pair of angles. Like if a ray falls on a straight line and forms two angles, so sum of these two angles is equals to 180 degrees. Sum of these two angles is equals to 180 degrees, that is angle 4 and angle 3. Their sum is equals to 180 degrees, and we call these angles are linear pair of angles. For linear pair of angles, as they are adjacent angles, the two non-common arms, this arm and this arm will form a straight line. It will form a straight line. This axiom is known as linear pair axiom. Linear pair axiom. What is linear pair axiom? If a ray falls on a straight line, then sum of the two angles is equals to 180 degrees. And if the sum of two angles on a line or two adjacent angles is 180 degrees, then the two non-common arms of adjacent angles, will form a straight line. So these two axioms is known as linear pair axiom. Linear pair axiom. So this is a linear pair axiom. So you have a linear pair axiom. So axioms, theorems we'll study in the chapter Euclid's Introduction to Euclid's Geometry. What is an axiom? What is theorem? What is the difference between axiom and theorem? Axioms are proven statements, already proved statements. That's why they are called axioms, and theorems we will prove this statements. That is the difference between axioms and theorems. Now this is about linear pair of angles, adjacent angles, and what it is vertically opposite angles. So this is about different kinds of angles and different types of lines. Now we will discuss theorem 6.1, that is theorem related to vertically opposite angles. Is it clear so far what I taught? Yes. Now theorem 6.1. What is the statement of theorem 6.1? If two lines intersect each other, two lines are given and the two lines are intersecting each other at a point. What we call these lines? Yes, these lines are known as intersecting lines. So they intersected each other at a point. Let AB and CD are two lines. AB and CD are two lines and they intersect each other at point O. At point O, this is the common point for both the lines and it is point of intersection and it is O. Then the vertically opposite angles are equal. As I said, when two lines are intersected each other, there are two pairs of opposite angles are there. That is angle AOC. This is angle AOC and angle BOD. This is angle BOD. Both are opposite to each other and we call the angles are vertically opposite angles. Now this statement says that this pair of vertically opposite angles are equal. That is angle AOC and angle BOD. Similarly, angle AOD, yes, this pair is also equal. Their measures are equal. Angle AOC that we need to prove it. So here, as I said, every theorem will have two statements. One statement will represent given data, the other statement we have to prove that. So here, what is the given statement, given data? If two lines intersect each other, so two lines are given, the two lines are intersected each other, that is the given data. So let line AB and CD are intersected each other at point O. Then what are the vertical angles which are formed? It is angle AOC and angle BOD. Similarly, angle AOD and angle BOC are equal. Then the vertically opposite angles are equal. Yes, we have to prove these two pairs of vertically opposite angles are equal. Yes, have you understand this statement? So from this statement, every theorem will have to prove theorem. Some headings are there as you come across even in the lower classes. First, given data. Given data. What is the given data here? That you should write. It is a line AB and CD intersects each other. Intersects each other at point O. At point O. Yes, that is the data. Two lines are given and the two lines are intersecting lines. They intersect each other point O. Now TPT, to prove that TPT or RTP also we use. Required to prove. RTP means required to prove. So what we have to prove? Vertically opposite angles are equal. What are the vertically opposite angles? Angle AOC and angle BOD. Angle AOC is equals to angle BOD. Similarly, the second pair of angles. What are the second pair of vertically opposite angles? Angle AOD and BOC. Yes, angle AOD is equals to angle BOC. Yes, sometimes to prove some theorems we require some construction. That construction also we have to write, and what construction we require that we should mention and we should draw in the figure. But to prove this we don't require any construction. Now go for the proof. So proof, yes, now we observe in the figure. So now here, yes, we need to prove, yes, these two angles are equals to 180 degrees. Sorry, the equal vertically opposite angles. Now we consider the line CD is the line. Yes, the figure CD is the line and O is the point. From point O, one ray is there. That is OA ray. This is OA ray. It is dividing the angles, straight angle into two angles. What are the two angles? That is angle AOC and angle AOD. It is these two angles. What we call these two angles? They are lying on the same straight line. We have in the common arm. They are adjacent angles and they form how much? 180 degrees, and we call them as one linear pair of angles. Linear pair of angles. So now you can write since angle AOC plus angle AOD is equals to 180 degrees. That is linear pair of angles. LPA, linear pair of angles. You take this as equation 1. So angle AOC plus angle AOD, that is angle AOC plus angle AOD, here I have drawn, will form one pair of linear angles and their sum is equals to 180 degrees. Similarly, you take the other line. What is the other line? AB. Yes, this is line AB. AB, and here we have a ray OD. OD is the ray, and here we have two angles. Yes, this is angle AOD and this is angle BOD. Two angles are formed, and these two angles are there on the same line with the common vertex O and having one common arm OD. They are adjacent angles and they form a linear pair. So angle AOD plus angle BOD is equals to 180 degrees. Now angle AOD plus angle BOD is equals to 180 degrees. Take this as equation number 2. Why they are equal? Linear pair of angles. They form linear pair of angles. So here, these two will form linear pair of angles on line CD, and these two will form linear pair of angles on line AB. Now, from equation 1 and 2, from equation 1 and 2. So, as the RH sides, we have 180 degrees and 180 degrees. Both RHS are equal. Therefore, their LHS must be equal. That is, angle AOC is plus angle AOD is equals to angle AOD plus angle BOD. Now, angle AOD and angle AOD both are there on this equality side. On either side of the equality side, there will be answer. Because if angle AOD is 50 degrees, this is 50 degrees and this is also 50 degrees. When we transpose to the other side, we will get minus 50 degrees and both will be cancelled, we will get 0. So, angle AOD and angle AOD are cancelled. Now, what is left? Angle AOC is equals to angle BOD. Yes, it is proved. What we have to prove? First proof, angle AOC is equals to angle BOD. Yes, this is angle AOC is equals to angle BOD. One pair of vertically opposite angles we proved. Similarly, we can prove. Similarly, this is the symbol for similarly. We can prove angle AOD. Angle AOD is equals to angle BOC. Hence, it is proved. Hence, it is proved. So, like this, we will prove this statement by using the concept of linear pair of angles. That is, if two lines intersect each other, then the vertically opposite angles are equal. Now, questions. If angle AOD is 40 degrees, then what is angle BOC? Yes, this is also 40 degrees because vertically opposite angles are equal. Vertically opposite angles are equal. Now, how much is angle AOC? How much it will be? Yes, as these two are linear pair of angles whose sum is 180 degrees. If one angle is 40 degrees, the other angle will be 180 minus 40. That is 140 degrees. This is 140 degrees. And what about angle BOD? Yes, exactly it is 140 degrees because vertically opposite angles. Yes, if we know one angle when two lines are intersected, we can find all other angles. All other angles. Sometimes the a pair of adjacent angles, the ratio will be given like 3:2 or 5:7. How do we find all other angles? We use this concept, this theorem, 6.1 theorem, vertically opposite angles theorem, and we can find all angles when the ratio of a pair of adjacent angles are given. Is it clear, children, this theorem and its application part? This theorem you have to remember, learn the statement, and whenever you are using this theorem, you have to write the statement. Vertically opposite angles are equal. Vertically opposite angles are equal when we are solving the problems. So application part will be where we use this concept. We use this concept to find the unknown angles. Clear?